Join the State 16 community webinar, live on Zoom, July 22 at 20x Israel time. Explore robotics, embodied intelligence, guardrails, open robotics ecosystems, and production-grade physical AI with leading experts. Register now
and we will move on to Dr. Mike Erlihson, that I believe that everyone actually familiar with Mike. I want to give some background, even though. So Mike, just make sure that Mike, is turned on. The microphone, I mean the other mic. So Dr. Mike Erlihson is a sessional AI leader. I'm reading right now. He's a data science expert and a prominent voice in the global deep learning community. And he holds a PhD in mathematics from the Technion, and he brings over 2 decades of experience pioneering advanced algorithm, machine learning model, deep learning neural network across industries like cybersecurity, NLP, computer vision, and agentic workflows, meaning that he touch everything. And he will present today the battle of the brains, the VLA versus the WAM. So, Mike, the mic is yours.
Okay, hello, folks. Good evening in Israel, and good morning in other countries, I guess. So today we'll talk a bit with I got used to give much longer lectures and presentation. I think the shortest one which I've given throughout all my life was 20 minutes. So this one gonna be very short, and it is called Battle of the Brains, VLA versus WAM or WAM. In my usual lectures, I like to make them interactive. So I'm asking the audience to answer some questions, but here I think it is less appropriate. I think Barak is not gonna love it, so I am not going to ask you questions, but you can ask me questions after my lecture and throughout my lecture. And WAM or WAM, I don't know how to call it, is Word Action Models, and the VLA is the Vision Language Action Models. And we'll talk about the battle, who is the best. Okay, so what is VLA? VLA is a quite old concept. I think it is with us for quite many years, which is it is widely used for building robots and also robotic systems. I will explain in what follows what is VLA and what is WAM. And WAM is a quite new paradigm, for the best of my knowledge. And the main difference of WAM from VLA is that it's taken into account the joint distribution of the state in action, and compared to the LA, which takes the current state and tries to predict the next action of a robot or a robotic system. Okay. The old guard, but by the way, presentation, I told by somebody that if I give in a presentation, I should give a disclaimer that this presentation was created by Gamma. Okay, this is Gamma app, so I recommend it. It is a great tool. It is not free of charge, but it's worth every dollar. Okay, I'm not paid for it. Okay, I'm not working for Gamma. So let's start from the VLA models, which was a dominant technique until the last years. Here you can see in the illustration we have some model which is taking a language instruction like push the toaster leader and some frame or which is an image or several images. And what is VLA basically doing? It's just trying to predict the next robot action or next sequence of action. And what is important that VLA is usually some massive fine-tune of vision language model. I guess you all know what is the vision language model. You just give it some text and some image, and the model is capable to answer questions about this image and do some segmentation and object detection and stuff like that. So they're taking such model, doing some fine-tune, adding a head or some complicated head, and we are turning it to vision language action model. And basically, for a given frame, we're just trying to predict the sequence of actions which is required to perform the language instruction which is given. So here, in order to train such a model, we're taking a lot of static images. By the way, as I already mentioned, it hasn't been a single image. It can be several last frame. We take images, we take text image pairs, and we take some gold demonstration of the robot, and we are just trying to train the model to predict the next action. You have a lot of models which were trained this way, and among them is Google Gemini Robotics and Pi Zero, and all this stuff. Okay, and what is the problem? This general problem. I wouldn't call this fatal because there are a lot of application of this paradigm, but it has some flaws, some shortcomings. And VLA, first of all, it has not acquired the world dynamics, so it just gets an image. And for a given image, it just tries to predict the next action. So it doesn't have the image, not image, the world state which WAM has, and it very naturally to assume, and it really does. It limits generalization. Okay. And the second one, and it is really important, and there are several papers about that. As I already mentioned, these VLA models are trained, are actually fine-tuned VLM, vision language model, and this fine-tune, and I'm reviewing papers. I've been reviewing deep learning papers, and I've reviewed a lot of papers. And there is a catastrophic forgetting during fine-tune, and I guess I reviewed several papers about it, and it really happens here with the VLA approach. Okay, two more flaws. The most important one, basically two of them are quite important. The important one that if we train this model on in some location, in one warehouse, it will fail even in another warehouse, which is a bit different. We have new lighting. You have different objects which is located in different position, and I don't even mention new tasks because you are training your model to predict tasks, to predict some actions, and if it is a different robot, you can't use this model unless you do some massive retraining. And here is the data text. The amount of data you need to train this model is really high, and training models is quite expensive. Training language models are quite expensive, and training vision language or vision language action models are even more expensive. So here we have so-called data text. Okay, there are some examples. Let's not stop on it. Okay, and let's start explaining about the challenger, and the challenger is the world action models or WAM, and what is WAM? And here the main idea is of using not just a VLM backbone, which we are fine tuning for VLA. We are using a video generation backbone. And we train it to predict how the world is, all our state for example, the state of a robot in the warehouse, and we are trying to predict how the world around us will change over time. Okay, and then why it is good? It is good because we are training our models to predict a joint distribution of the future state in action. So we don't just, like in VLAs, given some image which describes the current state, we try to and we predict the next sequence of action. Here we are looking at the at the image of the world. Okay, image when I say image, I mean in a wide sense. Okay, and here we train the model, kind of to understand the world, and if the model understands the surrounding world, it should be better in predicting the next action. Okay, and how it has worked. Okay, don't be shocked by the hallucinated future. I'm not talking about LLM hallucination. I'm talking about something a bit different. Okay, so as I already mentioned, we have a video backbone model, video prediction model, and in the first stage, WAMs actually predicts. You have video generation models, and what video generation models does, it is predicting next couple of seconds of the video. Okay, and it is exactly what it is done here. Okay, in the first stage, which is called Imagine in this slide, the model just generates some predicted future frames. For example, it may be several dozens of frames. Okay, and in the next stage, given this world state, okay, we are doing something which is called inverse dynamic prediction. So basically, we are taking this next world state prediction, then dynamic boundary model, and we try to predict what should we do in order, what robotic system should do in order to get to this state of the world. Okay, and why it is good? There are some claims. We have a lot of different and sometimes unjustified claims in the AI today. But here the claims in the papers are then that if it is trained on enough videos, video prediction models and video generation model are very data hungry, and if you train them on enough and on sufficient high amount of data, sufficient diverse amount of data, you can get the best performance. And here, if you train this model on enough data, these models can learn stuff like gravity and momentum and dynamics. And the claims are that these models are better than VLAs. Okay, there are some architectures of WAM, cascaded architecture and joint architecture. I think I'll skip this slide because it is details. Okay, and currently there are some benchmarks. By the way, I'd like to say a couple of words about these benchmarks. There are a lot of papers who invent benchmarks for themselves and then report very good results on these self-invented benchmarks. Currently, as far as I understood from the literature review, WAMs are outperforming LLMs on many benchmarks. Here you can see some results. It is not coming to say that WAMs are better than VLAs, because the situation is more complicated than that, but still in many benchmarks which are quite popular, WAMs are winning. Okay, and as for real world deployments, we have both. We have models which are based on WAM, and we have models which are based on VLM. And for example, GROOT model, The first version were based on VLA, and then they did pivot. Let me call it a pivot, and the next version is based on WAMs. And here are some numbers. So basically, these slides I came to say that there are a lot of work, and many labs are doing this. So VLAs are not going to die. There are many popular projects which are using VLA models. So this approach is not going to die. You can see here a couple of projects. Here you see here Pi 0 and Pi 0.5 is 12K plus GitHub stars and many contributors. And it was updated in June. I think it was updated in July. This slide was done in June, I guess. And there are a lot of models which are based VLA. Being okay, this is okay, and this is a very important. This is a very important claim. Okay, VCs or venture capitalist funds are still putting money on the company, which are developing models which are based on the VLA paradigm. So if many of them believe in this approach, I guess this approach is not dead. It's not going to die soon. Okay, this is a lead. This is by the way the leaderboard. You have here WAMs, and you have here also VLAs, and there is no clear winner. Okay, the WAMs usually win on robustness and novel environments, and it is perfectly understood because then you train award models, and if you train it well enough, this model will be good will generate better for new environments and VLAs, and it is also not very surprising, is better in training efficiency and in the terms of deployment maturity. It has a much more deployments because it is just older.
Mike, this is exactly the point that we will say thank you, and it was really great talk, and I really enjoyed to listen to you, and it was
okay. May I present one slide, Barak? Just one slide.
Let's do a vote on that, or just give you the opportunity.
Okay, because I haven't, it basically took a bit more time than I expected. Maybe I should have talked faster. So what is the future? Okay, I don't believe that some specific approach will win, and all the other approaches will die, like in hybrid LLMs. Here, I really believe in synergy, and there are a lot of models and labs which are actually combining this VLA and WAM models and building, and utilizing the best feature of both. So in this battle, there are not going to be a clear winner. It will be a synergy. And thank you very much.